Hello everyone, I welcome you on to my channel. The topic we want to discuss today is surd. Surd simply means number that cannot be expressed in fractional form. That is, those numbers cannot be written in form of one number divided by another number. The only way of expressing what is called a surd is decimal form, and its nature of decimal is that it is not recurring type, so the list just continue forever or to infinity. So that is the aspect of definition. What of utmost important to us here is how to identify a number in surd form, and any number that satisfy this requirement of surd must be in its basic form, or what we call its simplest form. And for a number to be in its simplest form, the number must be written in such a way that even when it is divided, no two number will repeat itself. So those are what defines the basic or the simplest form of what? Of surd. A good example of number that cannot be expressed in this fractional form are root 2, root 3, root 8, root 7, pi, and so on. By its nature, it is a decimal that continues forever. So what we want to talk about now, or to establish now, is how do we know whether any number is in its basic form or not? So that will lead to our first example. So example 1, check if each of the following numbers are in their basic form. 1, root 50, 2, root 2, 3, root 12, and 4, root 7. So solution. So to number 1, so I will write the number given to me there, that is 50. So to check whether this number is in its basic form or not, what we have to do is I can position 50 somewhere else where I want to do the rough working, and I will go and reduce this number until it becomes 1. Reducing it there means I will continue dividing it with a given number, with a given prime number, until this number becomes what? 1. So the simplest of the prime number I can use to divide it is what? 2. So 2 in 50 here gives what? 25. And the next number we can use to divide this is what? 5. 5 in 25 here gives 5, and 5 in 5 here gives what? 1. So we can see that 50 can be expressed as what? 2 times 5 times 5. So we now say that this number is not in its basic form. The reason being that what? There is a particular number when we express this number that happened to what? To repeat itself. So 50 is not what? In its simplest form. Now in number 2, what I have there is what? Is 2. So let me see, is it possible for me to re-express 2? So I can write 2 like this and divide 2 into 1. Remember, the essence of this aspect is to turn this number to 1. Now it has changed to 1. So you can see that the only number that is used to cut these two, to divide these two, is 2 itself. So it shows this number is, in its case, we don't have any number that repeats itself. So we say this number is in its basic form. So when we compare this to this, we can see that in this case, we have some numbers that repeat itself. Whereas in this case, no number repeats itself, 2 occurs singly here. So the 2 in this case is in its basic form. So we say root 2 is in its basic form. So the next number I have is root 12. So in order to detect that is to do what? To first of all re-express this number. So when we re-express 12, the result we are going to get is this: 2 in 12, 6, 2 in 6, 3, 3 in 3, 1. So we can see 12 can be rewritten or broken down into 2 times 2 times 3. So we can see this number as well, 12, is not in its basic form because there is a particular number which is repeated here. So we say is not in its basic form. In number 4, the only number I have there is root 7. And we can see very well that when 7 is reduced to 1, only 7 will be used in doing that. And we're also going to observe in this case that what? No repetition of any number occur in this case. So we say root 7 is also in its basic form. And what we actually want to talk about in Surds is any number given to us, we want to ensure we take them back to their root. We take them back to their basic form. So from that, then we now be able to do what? To simplify or do whatever which we are asked to do. So we now move to an aspect which talks about what? Simplifying. So in that case, I'm going to illustrate it with example. So example 2. Example 2 here, simplify the following. So number 1, I have root 50. Number 2, I have root 360. Number 3, I have root 125. Number 4, that is root 500. And finally, number 5 is root 108. So solution. So number 1, I have to write my number as given above. 50 is going to be, remember the first thing we want to do is to write 50. So writing it means I'm going to divide this 50 until it becomes 1. So that can be achieved here. So if I have my 50, 2 in 50 here give 25, 5 in 25, 5, and 5 in 5, 1. We can see that 50 can be rewritten as 2 times 5 times 5. So to continue means we are going to break this number. We want to regroup them. We group them in 2 so that this big root I have here is going to be splitted into different roots, whereby in each root I'm going to place just 2 numbers, but not just 2 numbers. The 2 numbers I'm going to place there happens to be what? 2 numbers that are the shade that are alike. So this is going to be 5 times 5 multiplied by root 2. Normally in each of the roots, we want to break this bigger root 2. We want it to be a smaller root that will comprise of just 2 numbers. And those 2 numbers we want to be there are the type that what? That are the same thing according to the division which we carried out here. But in situation whereby we are left with just a number, so it's only that number that will fill or occupy the last or the final root. So unlike what happened in this case. So our result now is going to be, so the reason why we want same number to be here is that it will allow us to be able to what? To write all of the 2 numbers without having the root again. Because what we really want to achieve is we don't want to do with the root again. We want the root we want to release the root. We want it to disappear. So for the root to disappear here means I will just write one of the 2 numbers here. So that becomes 5. Multiplied by, since this one is not up to 2, there is no way it can escape this root, so the root will remain there. So finally the result that gives is what? 5 root 2. And remember, multiplication of such means that what? numbers not in root can only multiply numbers not in root, while numbers in root can multiply number which is also in root form. So the assumption here for me to arrive at 5 root 2 means that since this one is 5, then it can only multiply one number here, the coefficient of this root. And we know when any number, any letter is given without it having a coefficient, we assume it to have what? A coefficient of 1. So 5 can only multiply this 1, but it's not powerful enough to what? Go inside and multiply the 2. So when 5 multiplied by 1, I got 5 root 2. So the result there is what? 5 root 2. In the other aspect, that is in number 2, what we have there is root 360. Remember, the first procedure to solving this question is what? To go and re-express our 360. So re-expressing it means we want to reduce it, we want to cut it, we divide it until it becomes 1. So 2 in 3 here 1, 2 in 16 here 8, 2 in 0 0. 2 in 180 here give 90, 2 in 90 give 45, 3 in 45 15, 3 in 15 5, and 5 in 5 here gives 1. So we can see that 360 is the same thing as saying that what? 2 times 2 times 2 times 3 times 3 times 5. Remember, they must be in root. And the next thing is what? We have to regroup. And the essence of grouping is we want number of the same type to be in the root. So that is the first thing which we are going to consider. So it means this 2 and 2 will maintain one root. This is 2, but this is 3. So since there is no other 2, we move over to another number that is also repeated in our expression here. So the next number we have is 3. We can see 3 is also repeated. Why this number that doesn't have anything to match it with, and this one that doesn't have anything with which it can be matched, will now be matched to this. So the result that now gives is what? 2 times 2 multiplied by 3 times 3 multiplied by root 2 here times 5. And the result that gives is, if you remember the way it's explained above, this one will become 2, this one will become 3, this one will now become. So since these numbers which we have here are different numbers, so there is no way we can change them to one number that we escape this root. So which means the only way to do this one is to call it what? 10. So and the answer we are going to get here is going to be 6 multiplied by root 10, and the final result here is what? 6 root 10. So that is question number 2. So in number 3, in number 3, what I have is this. I have root 125. And remember, the first solution to it is that what? This 125 we have to re-express it, so we can still maintain this our corner for the possible division. So 125. So 5 in 125 is 25, 5 in 25 gives 5, and 5 in 5 here gives 1. So it means 125 can be written as 5 times 5 times 5. So after this is what? The grouping. So we group this and this, 5 times 5, multiplied by, since we are left with only one number, so it's only that number that is going to maintain this root. And the result that this gives is what? 5 multiplied by root 5. And the final result we get here is what? 5 root what? 5. Then the next is number 4. And what we have in number 4 is we are asked to simplify root 500. So root 500 becomes, so we can come here 500. 2 in 500 here is 250. 2 in 250 is 125. Then 5 is the next number we can use. 5 in 125 gives 25, 5 in 25 gives 5, and 5 in 5 gives 1. So it means 500 can be written as 2 times 2 times 5 times 5 times 5. The next thing is to group this number. So grouping it in 2 becomes 2 times 2, that is this and this, this and this. multiply by 5 times 5, multiply by, since I'm left with only one number, so only that number will maintain this final root. And the result of this one becomes 2, result of this one becomes 5, while this one has no result other than what? To write it as what? Root 5. And finally the result that gives is 10 root what? Root 5. And finally in number 5, what we have there is root 108. So doing this one, that is solving it, involve breaking it down first, re-expressing it. So to re-express 108, so 2 in 10, 5, 2 in 8, 4, 2 in 5 here is 2, 2 in 14 here is 7, 3 in 27, 9, 3 in 9, 3, 3 in 3 here gives 1. So it means 108 can be rewritten as 2 times 2 times 3 times 3 times 3. And the result that gives, we now have to what? To be grouped. So we group this and this, this and this, while this one will maintain what? A single root. So that becomes 2 times 2, multiplied by 3 times 3, multiplied by root 3. And we know the result of this becomes 2 times, result here becomes 3 times, the result here is root 3 itself, because it is in its basic form. So the final answer we're going to get here now is 6 multiplied by root 3, which finally becomes 6 what? Root 3. So this is the first thing which it is required of students to learn as far as what? Surd is concerned. And that is on how do we simplify, how do we break down any given number to its simplest form. Now the next thing is, how do we carry out some basic operation involving surd? The operation which we are talking about are the operation that has to do with addition, subtraction, division, as well as what? Multiplication. So we shall start at the moment with what? The one that has to do with addition. Now simplify the following. Number 1 there, root 48 plus root 12 plus root 12 minus root 75. Number 2, 3 root 2 plus 4 root 2. Number 3, 6 root 3 minus 8 root 3. And number 4 there, so let me place that here. Number 4, I have 4 root 72 plus 2 root 50 minus 3 root 18. 3 root 18. Before I go ahead to doing this, my addition or subtraction, there is one concept of similar root that we are supposed to discuss. What we mean by similar root is this: when we have a root containing the same element, when it contains the same element like this, we say this root is similar to this root. But what about this situation when I have root 2 against root 3? So you can see the number or the element inside this root is different from the element inside this root. So since the element they are having are not common, are not the same thing, we say these two roots, these two surds are not similar. And for us to carry out addition of surd, so we make use of what? Similar roots. It's only when the roots are similar that we are allowed to add. Because what we simply do under the case of addition and subtraction is that, number one, we want to reduce whatever number is given to its basic form. So when it's reduced to its basic form, the next thing we want to do now is we consider the coefficients of each root. So it is those similar, it is the coefficient of those similar roots that only can be added. So since we have the example, now let's move ahead to solving them. So number 1, I have root 48 plus root 12 minus root 75. Solving this thing means I have to take this thing back to its simplest or its basic form. So doing that means I will have to re-express each of the numbers which I have here. So the only number that may not need the expression is any number that is in its basic form, and I'm very sure that every student understands that all the numbers we have in this case, none of them are in their basic form. So it is necessary I reduce this one to its basic form, this one to, and this one to. So doing that means I will begin with 48. So we can see 48, 2 in 48 is 24, 2 in 24 is 12, 2 in 12 is 6, 2 in 6 is 3, and 3 in 3 is 1. So 48 in this case becomes, it may not work like this, becomes root 2 times 2 times 2 times 2 times 3. So with this, we've been able to re-express our 48 plus, I also have root 12. So re-expressing 12 becomes 2 in 12, 6, 2 in 6, 3, and 3 in 3 here, 1. So 12 is going to be written as 2 times 2 times 3 minus 75 as well will be written as 3 in 75, 25, 5 in 25, 5, and 5 in 5, 1. That's going to be 3 times 5 times 5. And we'll break this thing down into 2. So the smaller root or surd will be used. So that becomes 2 times 2 multiplied by 2 times 2 multiplied by 3, since it's the only number which we have here, plus 2 times 2 multiplied by root 3 minus 5 times 5 multiplied by 3. And we know the result of this becomes 2. The result of this becomes 2. The result of this one is still 3, since it is in its basic form. Plus the result here is 2 multiplied by root 3, since it is in its basic form, minus the result here as well is 5 multiplied by root 3. And that becomes 2 times 2 times root 3. There we have 4 root 3 plus, for this one 2 root 3 minus, and in this case is 5 root 3. And the next thing is, let us check, is the addition possible? Addition simply means, or subtraction, what it means is we should go and check our root, our surd. Are the surds similar? So if they are similar, we can progress with adding or subtracting. But if they are not similar, addition is not possible and subtraction is not going to be possible, so we will rather leave the result like that. But when we observe this one, we can see that the surd which we have here is root 3, the surd we have here is root 3, the surd we have here is root 3. So in each of these, first case, second case, and third case, everything, so this is a case of similar surd. So once the surd are similar, then we can progress to adding and subtracting. So that now means coefficient of the surd here, coefficient of the surd here, as well as coefficient of the surd here can be manipulated. So that now gives the result of 4 plus 2, 6, and 6 minus 5 gives what? 1, which will give what? 1 root 3, which we can as well be written as what? As root 3. So that is number 1. So in the second question, what we have there is this. In number 2, I have 6 root 3 minus 8 root 3. Now remember, our first target is the root here, this surd and this surd here. Let us see, look at the element here. Is it in its basic form? this element, is it in its basic form? So from the what we have learned so far, we supposed to know very well that this thing is in its basic form and this one is in its basic form. So once it is in its basic form, then the next thing is to consider. Remember, we have to subtract here. Is subtraction possible in this case? And only one thing in this question will tell us if the subtraction is possible. And that thing that will tell us whether the subtraction is possible is, are the roots, are the surds, are these surds similar? So this is root 3, this is root 3. You can see it is the same thing. The same elements are inside this root as well as inside this root. It shows the surds are similar. And whenever the surds are similar, subtraction is possible. So we can subtract. And what we really want to subtract here are the what? Are the coefficients. So in this case, I can now say that 6 minus 8. We know the result of 6 minus 8 is minus 2. So our result now is going to be minus 2 root 3. That's number 2. In number 3, what I have is 3 root 2 plus 4 root 2. Solving this one also involves checking the surd aspect of this thing to determine whether it is in its basic form. So we can see this root 2 is in its basic form, as well as this one here, it is in its basic form. So once it is in its basic form, then the next thing is to think whether we can add the two values, the two expressions which we have here. And we can see that addition is also possible because this surd is similar to this surd. And this surd is different from this surd. Addition will not be possible. But addition is possible in this case because the surd here, that is the element inside this root, is the same thing as the element inside this root. So I can now go ahead with adding their coefficients. And what are the coefficients? 3 plus 4. So the result of adding 3 to 4 gives what? 7. Then with the common what? Surd. 7 root 2. And that is also result to this. And finally, in number 4, we have 4 root 72 plus 2 root 50 minus 3 root 18. So remember, the first step to doing anything here is to check whether this our surd is in its basic form. So we can see this not in basic form, neither this nor this. So it's the first requirement of this question is we have to reduce them to their basic form first. So that becomes 72 as given here. 2 in 72, 36. 2 in 36, 18. 2 in 18, 9. 3 in 9, 3. 3 in 3, 1. Then the other one, 50. 2 in 50, 25. 5 in 25, 5, and 5 in 5, 1. And finally, I have 18. 2 in 18, 9. 3 in 9, 3. 3 in 3 here, 1. So I can go ahead with the simplification. So this becomes 4 root. Remember, root 72 now becomes 2 times 2 times 2 times 3 times 3 plus 2 root 2 times 5 times 5 minus 3 root 2 times 3 times 3. And what we want to do now is to regroup them. This root is too long. We want to break it into shorter one that will comprise of just 2 elements. So I will combine this and this and this, since this is the only single one there. So that becomes 4 multiplied by 2 times 2 multiplied by 3 times 3 multiplied by root 2. In this first case, this root 2 will come last here, plus 2 times, so I have to consider this one first, 5 times 5 multiplied by this root 2 here, minus 3 times, this one we also have to be considered first, 3 times 3 multiplied by root 2. And remember, this becomes 4 times, the result of this is 2, result of this is 3, multiplied by, the result for this one is going to be root 2, plus 2 times, the result here is going to be 5, multiplied by root 2, minus 3 times, the result here is 3, multiplied by root 2. And that gives 4 times 2 8, 8 times 3 24. So we have 24 root 2 plus 2 times 5 here 10 root 2 minus 3 times 3 here is 9 root 2. So we are able to reduce the number given here to their basic forms. So after it has been reduced to their basic form, we now consider whether addition and subtraction as given here is possible. And the only thing that will tell us whether addition and subtraction is possible here are the surd which we have now. Now the surd here, and the surd here, are they the same thing? So we can see that this is root 2, this is root 2, this is root. So they are all similar. So once they are all similar, addition is possible. Remember, the only thing that will tell us whether to add or to subtract is if the base, if the surd are similar. Now that we can see that the surd are similar, we can go over to addition. And what we do there is we only add or subtract the coefficients. So that gives 24 plus 10 here, that is 34. And 34 minus 9 here gives what? 23. So the result here is going to be 23 root 2. So, and that is how far we can go with our class today. So in the next class, we shall continue by God's grace with the multiplication as well as division and finally the surdical equations. But before we call it a day finally in this class, I think it's going to be of benefit. I also leave the student with some classwork with assignment. So this is the assignment. Evaluate the following. Number 1, 3 root 28, 3 root 28 plus 4 root 12 plus 4 root 112 minus 5 root 63. Number 2, root 99 minus root 44 plus root 11. Number 3, 2 root 18 plus 2 root 54 minus root 108. Number 4, 3 root 2 minus 5 root 200 plus 30 root 8. And finally is number 5. That is root 40. That is root 32 plus root 72 minus root 128. Thanks for watching.